Yes. All right. So probably you can see one presentation. Okay. Can you please respond once? Yes. Okay. That's nice. Okay. If you can't see anything, then just give me some ping. I can understand. Okay. So
No,
thing
sir.
is that, all right. That's very good. The thing is
Yes,
that, as
sir.
I said, okay, okay, good, good, good. So as I said, the process plan. So process plan means, in a brief, the concept of process plan means is a combination of unit process and unit operation. Okay, you have to know unit process and you have to know unit operation. What are the unit operations? Unit operations are mostly physical operations like drying, crystallization, compression, blowing. Okay, some other heat exchanger operation. Okay, these are all unit operation because there is no involvement of any chemical reaction. And unit process means there are somehow there is the involvement of chemical reaction. Chemical reaction means there will be stoichiometry, there will be kinetics. Okay, and in the process plan you will have a unit operation. You will get the unit process as well, because what process plan is doing, it is converting certain raw material into product. So chemical change means change of chemistry. Okay, so if you want to change the chemistry, you have to go for reaction. Okay, this is the only way. So by default you will have the unit process, and once you change the chemistry, there will be product. That product you need to take it out from the system. So there will be separation technique, there will be distillation process, crystallization process. Okay. These are all unit operations. Okay, so unit process is clear, unit operation is clear. So now the point is pump. Why pump plays an important role? Because when you face interview in a year, you see this pump, heat exchanger, distillation column. These are very common topic that is often been asked during interview. Okay, what are the different types of pump, how pump works, what is the performance curve? Okay, and how to calculate the hydraulic equations. Okay, and what are the different parameters that for NPSA is. Okay, that I'll show one by one. So now if I move to the broad classification, there's a two type of pump. One is called centrifugal pump, another is called positive displacement pump. Okay, non positive displacement means centrifugal type. Okay, so under non-positive displacement there is a centrifugal diagonal axis flow. This is not much required. This important is here centrifugal type. This is most important. And another most important part that I was explaining to you, this is the positive displacement pump. Okay, positive displacement pump, you see in the industry, in manufacturing process, you'll see around 80-85% there will be centrifugal pump. Okay, and around 10 to 15% there will be positive displacement pump. So the population of centrifugal pump is very high because of its wide utility and wide applications. So what does pump do? It is a hydraulic device which is converting this velocity into the pressure energy. Okay, so that is the basic principle of a pump. Because when the fluid is coming in contact with pump is rotating at a very higher speeds. Okay, the speed is basically maintained with the help of a motor. These are mostly induction motor. So motor is rotating means pump is rotating. So when the fluid is coming in contact with the pump, it is imparting its energy, velocity energy, kinetic energy to the fluid. So once energy is being imparted on the fluid, so pump is doing what is imparting the kinetic energy to the fluid. When that fluid is coming through the volute, okay, it is passing through the volute because of the gradually increasing cross section area. That kinetic head is getting converted into the pressure head. So the pump is what doing the rotor part, the rotary part of the pump. It is imparting the energy to the fluid, that is the kinetic energy. Then fluid having very high velocity. Once that high velocity is moving through the volute is the harder of the pump. This is the gradually increasing cross section area. So gradually increasing cross section area, you know this concept of the continuity equation. The increasing cross section area means reducing the velocity. So you know the Bernoulli is also, once the velocity is reduced, it has to convert to the other point. That is a pressure energy. Okay, so that is the main role of a pump. So it is basically boosting a certain pressure to another level of pressure. So that pressure is required in the process. Okay, so that you can do with the help of centrifugal pump, and you can do with the help of positive displacement pump. Why centrifugal pump you widely use? Because centrifugal pump, normally it is mostly centrifugal pump. We can use for the higher flow, and we can use for the even higher flow, higher head also by the multi-stage concept. But positive displacement pump generally used for the very low flow and very high pressure. Okay, gear pump, screw pump, these are the commons. So this is how a pump looks like. Okay, if you see a pump, So pump is here. Okay, the horizontal line is the supply line and the discharge line is the delivery line. Okay, so some fluid is coming at the pump suction. So as I said, the pump is rotating with the help of motor. And the yellow part, if you see, this yellow part is nothing but shaft. Okay, so pump is motor is imparting energy on the through the shaft to the fluid. When this fluid is moving through this volute casing, it is gradually this kinetic energy is getting converted into the pressure energy. So maybe a pump is designed for differential pressure 5 kg. That means if suction pressure is 1 kg, discharge pressure will be 1 plus 5, 6 kg. So it is boosting a 5 kg pressure. Okay. And this is the configuration how it looks like. This is, this is a grouting, this is called foundation. Okay. On the foundation, there's a motor and pump is there. And motor, this theory of motor, there's a, probably you have gone through this very basic theory like B.L. Thereja, this book is there. Okay. There's Lenz's law, there's a Fleming's law. How does this motors rotate? Three-phase induction motor. Same like centrifugal pump. If you go to the industry, you'll see around 90% these are all three-phase induction motor. Few cases, in few industry, maybe 1 to 2 cases, or you can get the synchronous motor where there is no slip loss. Okay, magnetically coupled. Otherwise, 98% cases you will get this three-phase induction motor. Okay, so this motor working principle you have gone through probably. The first stator will be having this current, then since this phase induction motor, then there will be magnetic field and rotor will be the conductor in the magnetic field, then EMF will be induced and try by Lenz theory, it will try to rotate to capture this, to get this, achieve this rotating speed of the magnetic field. Okay, so for this rotation is happening, and there's a shaft also rotating in the same speed, then being transmitted into pump having rotor, and this rotor is imparting kinetic energy into the fluid. When that fluid is passing through the volume, gradually converted into the pressure energy. Okay, so that is the basic principle of a pump. And this big cable, if you see this left hand side, these are called power cable that is giving supply to the pump. The small cables, these are all earthing cables and everything is there. Okay, so this is side view. Side view also looks like this. This part is called coupling. Why this coupling is used? Because it helps to isolate the pump with the motor. If there is a motor problem, you can isolate it from the coupling. No need to take out pump, and if there is a pump problem, you can isolate from the coupling. Okay, so that is the purpose. This is a sectional view. What I have explained to you, this yellow color is the impeller part, and the suction line, if you see in the left hand side, fluid is entering here. This is basically axially in, radially out. Okay, centrifugal machines are normally designed for axially in, radially out. Okay, so axially it is getting in, radially it is getting out. Okay, this is called volute. And this just nozzle bearing, why the bearing is there? Because bearing is helping the shaft to rest on its position while rotating. Otherwise, this impeller will touch on the casing. Okay, this is the mecha seal, this oil seal, this for lubrication. Okay, so these are the basic purpose. This is the impeller. Okay, so this impeller, if you see this impeller, it should rotated in the backward curve design. Okay, backward curve design means the principle you have to remember. The thing is that since it's not rotating on the animation now, if you see there's a forward vein angle. Okay, if this is used for mixing purpose, for degree of homogeneity of certain mixture, then it should rotate in the forward vein angle. Okay, so if it is used for pumping purpose, like a centrifugal device case, it should rotate in the reverse vein angle. Reverse vein angle is used to improve the pressure, improve the kinetic energy. But forward vein angle, if you use, then it will not improve the pressure, it will increase the degree of homogeneity in the mixture. So whether this impeller is a part of agitation or it is a part of pumping, that you can understand by checking the vein direction. Okay, or whether it is rotating in the forward vein or it is rotating in the backward vein. Okay, so that is the basic principle you have to remember for centrifugal machines. So one principle I said is this in and out part, that axially in, radially out. Second one is, as I said, it should be backward vein design to act as a pump. For pump it is same, for blower it is also same. Fan, you can see it is a flat blade type, so it doesn't matter which direction it is rotating. But for blower and for compressor and for pump, these are mostly same, because more or less, apart from this compressible and non-compressible fluid, the concept is more or less same. Okay, so this is how a closed impeller looks like. The impeller can be closed impeller, open impeller, and semi-open. Okay, these are some impeller types. Okay, and this you can see here. Okay, so this here you can see this is guiding the air. This is inlet. Okay, Now imparting this kinetic energy to the air. Okay, what does this thing? This is the impeller. Here it is written. Now moving here, guide the air to the outlet, gradually increasing cross section of casing helps to drop in kinetic energy and develop pressure head. Okay, so this is how the things moves on that I explained to you. What is about the centrifugal device? Okay, just please remember few basic thing as I was telling to you. This hydraulic calculation. This is called Hagen-Poiseuille equation. This is most commonly used equation in industry calculation. Okay, delta P by L 4 F rho V square by 2 GT. So please remember this equation. This will be used for the hydraulic calculations in the pump. Okay, affinity law. This is often been asked in interview. Okay, so if you change the diameter of the pump or if you change the speed of the pump, how does the flow will vary, how does the pressure will vary, and how does the power will vary? This is also very commonly asked question in interview. Please remember this affinity law also. Okay, so Hagen-Poiseuille equation I explained, affinity law I explained to you. Now I'll show you this pump performance curve. Okay, how it looks like before going into another part. Okay, I'm just closing this one and I'll show you on performance curve. Okay. So now another most important thing. Yeah, I understand network issue. Every has the same network issue. Okay. So, okay. Just wait and see. So basic thing is there. I think this PDF you can see on PDF. You can see on PDF. All right. So if you, yes, that's good. Okay. So if you want to buy a pump, okay, you have to give some specification. So like if suppose I'm buying a pump, so I need to specify the liquid, I need to specify the temperature, specific gravity and viscosity. Okay. So these are the very important parameters. Okay, that you have to say, and this flow and differential head. Okay. So like suppose as I was giving an example other classes also. Uh, the thing is that has these properties are called thermophysical properties. Thermophysical properties means the properties which varies with temperature. Okay, like specific gravity it varies, viscosity is varies. Okay, so these are important. And other part is if it is a design for a heat transfer equipment, that where the most important parameter other than this density and viscosity is, and that is the thermal conductivity and heat transfer coefficient. Okay, so these two part you have to specify there also. Okay, thermal conductivity is how much, and this heat transfer coefficient also how much. So if it is a heat transfer, but it's not a heat transfer equipment, here we are developing the pressure in the pump. So flow is important and the differential head is also important. NPC is available. Okay. So these are the parameters you have to specify if you want to buy a pump. So now rest of the thing is designed by the vendor. Okay, they have particular software. They say how much is the rated pump efficiency, power, overloading power, suction specific speed, all these things. So the important part as a student is this to look how this pump performance curve looks like. Okay. So if you see this performance curve, there are HQ characteristics. HQ means in the x-axis there is the flow, okay, and y-axis could be head, it could be efficiency, it could be power, or it could be MPSH. Okay, there can be four parameters. Okay, so now see if there is one line here, there is another line here, and there is another line here. These three lines is specifying certain impeller diameter. Okay, it is mentioned here. This line is specifying for impeller diameter 422 millimeter. This is 305, and this is how much? Another is 403. You have to point out this point. Okay, this angle point. Okay, this angle point specifying that this pump is having this 403 millimeter. Okay, pump does not have this higher impeller dia and lower impeller dia. The operating impeller dia in the pump is 403 millimeter. Okay. By this you have to understand. And this point is called best efficiency point. Okay. So normally the pump capacity like 157 and 215, it is given based on the best efficiency point. Okay. If you just make a vertical here, it will be somehow 157. And if you make a horizontal here, then you can get the pump head is around 215 meter. Okay. So by that way you can get the efficiency here also when it is intercepting the efficiency curve. Okay, and if you plot it in vertically down, then when it is intercepting the power curve, it will get the power intercepting the NPC R part, NPC required part, you will get the NPC required. Okay. So this way you have to specify the point where the pump is operating. Now this is called best efficiency point. So there is a guideline of APA 650. this operating point of the pump, it should be somehow 80 to 110% of the best efficiency point. So you have to select your pump in such a way, you have to justify your pump requirement in such a way the operating point should be in between, okay, maybe in between maximum, okay, 80 to 110% of this point. That is maximum allowable, okay. So if you operate this pump over here, you get a maximum efficiency, otherwise there will be losses. So in that case, there will be a very nice concept in industry, what is called impeller trimming, or somehow, or some places it's called impeller size up. Size up means in the vendor curve it is given that you can go up to maximum 422 millimeter and minimum you can go up to 305 millimeter. So impeller trimming means if you are bringing down the size, that is called impeller trimming, like we do hair trimming, okay. And if you increasing the size of the impeller, then this is called impeller size up, okay. So this is called impeller size up, okay. So impeller size up or impeller trimming, in any case, as I shown you, is affinity curve concepts. By that affinity curve, you can understand how much would be the flow requirement and how much would be the change in pressure and how much would be the change in power. Okay, for power case it is cubic. Okay, for pressure case it is square, but for flow case it is directly proportional. Okay, with the speed or with the diameter of the vehicle. Same, you can vary the speed also, keeping diameter fixed. So that case also it will follow this concept. Okay, so now the point is you cannot vary the speed of a pump. Why? Because you should have a very variable speed drive. Okay, all the pump, mostly 90-95% cases pump, there is no variable speed drive. Okay, in some cases if it is a big kilowatt pump or power consumption is very high, or you require sudden throughput up, sudden throughput down, flow up, flow down. In that case, it is being recommended to use for, because cost is also important, because you have to get the payback. If you are investing something, you have to see that how after how much time you get return your money. Okay, so once you do this calculation, there's in chemical engineering there are many concepts are there. One is called IRR, internal rate of return. Okay, there's another concept is payback. Another concept is CAGR. Okay, so based on different concepts, it's calculated that what would be if you investing something, then after how much time it is your money is taken out from the system. Okay, that you have to understand, you have to analyze. This is called techno commercial viability. Okay, so the important thing I have to explain one here. Suppose you have explained here that you require this 157 meter cube, and you require this 157 meter cube and 250 meter. So I said that once you give this data to the vendor, they will design the pump for you. Okay, so now the question is, suppose if you give 157, they will design one pump. Suppose if you give 167, they will give design another pump. If you give 147, 137, is it true? The question is, it is not true. Okay, because the same concept, if you want to buy a mobile phone, okay, suppose if you have a 10,000 rupees in your pocket and you go to the mobile store, you want to buy a mobile phone. Okay, you give to the store the 10,000 rupees I am giving, please give me a phone of 10,000 rupees. It is not, because if the phone is available 9,500 you have to take, or it is available 11,000 you have to take, they will not make phone for you at 10,000 rupees. Same for pump, same for all the equipment. Okay, if you give a specification of 157, they will not make 157 pump design for you. Okay, they will give some available model that will satisfy the requirement. Okay, maybe they are having model of 165, or maybe they are having model of 170, so that they will ensure that it should fall 80 to 100% of your requirement. Okay, so this way the selection is being done. It is not done that you have a 10,000 rupees, you have to buy 10,000 rupees mobile, it is available. It's not that. Okay, same way it is applicable here also. Same way it is for the control valve also. If you want to have a control valve with certain flow requirements and pressure drop requirement, if you go, they will not design for you. It's available already in the system. One of the model, you have to select. There can be revamping also. There are options are there, like port size up, all these things, CV up, concepts is there. So this is the concept of the this performance curve. This is very important for a reciprocating pump. Positive performance curve is y equal to x. Okay, if you increase the stroke length in the x-axis, gradually flow is increasing. Okay, but for centrifugal machines, the performance curve is like that. Same for compressor. Compressor case, we do not call this performance curve. For compressor case, we call it surge choke characteristics. Okay, there will be surge graph, there will be choke graph, there will be operating point. You have to navigate the operating point in between the surge and choke to avoid any damage in the compressor. Okay. Same for the compression is the compressible fluid. Pump, as I said, is the incompressible fluid. Same thing is valid for other machine like blower also they are having performance curve. So this way you have to analyze. And there are two important factors. One factor is written here, the suction specific speed. This is called NSSS. NSSS, suction specific speed. And there is another concept is called specific speed, that is called NSS. Okay, this is N triple S. So how to calculate this? How they have calculated this? There's a formula. Okay, formula is this: success specific is speed equal to speed into q to the power half. NPC is required at BEP point to the power 3/4. If you calculate this, it come 13086. Okay, it has come here also 13086, 13206. Okay, it's close to that. So specific speed, there's a formula also. There are certain guideline is there when you select the pump. What should be the specific speed range? What should be the success specific speed range? All this. So this way it is being done. So I'm closing that. So now I'll show one hydraulic calculations for your understanding. Okay. So you see how to do this hydraulic calculations. Now you can see one Excel. Suppose just follow over here. Okay, this type of calculations you have to do in the industry. Okay, suppose one pump having flow of 21 meter cube, gravitational acceleration 9.8 meter per second square, head is 101 meter, density is 1.03 kg per meter cube. Okay, so 1.03 kg per meter cube. This is not kg per meter cube. This would be ton per meter cube. Unit is wrong here. Okay, so hydraulic power you have to calculate. Okay, you have to calculate the shaft power, you have to calculate the pump efficiency, all these things. How you do hydraulic power calculation is the formula is rho q gh by 3600. Okay, hydraulic power is nothing but the power that is required to do certain work by the pump. Okay, why it is rho q? Because it is nothing but h into rho into g, potential energy, certain height pump the liquid has to lift up. H means certain height, rho means rho density, and h into rho into g. Okay, so h into rho into g, same way it is happening. Okay, like m into g, m into g into h. Okay, for h rho g it is for pressure, for certain potential m into g into h. Okay, m means mass means what? It is nothing but volume into density. Okay, so same way it is being done here. Okay, I'll share this Excel. You can get the calculation. So this is called hydraulic power. Shaft power, how to do? Have shaft power you have to do. You have to see certain efficiency here. Okay, by this efficiency we have to do this shaft power concept. Okay, so next it is coming this pump efficiency and motor power. The same way, if you divide it with motor efficiency, you get the motor power. Okay, so you see that work done power is only 6 kilowatt, but motor is taking around 37 kilowatt. So why this difference is going 30 kilowatt? 30 kilowatt is total loss in the system. Okay, so that you have to understand what are the losses are there in a pump. It can be entry loss, it can be exit loss, it can be bend loss, other cases. What are the losses in the motor? The motor losses you have gone through. It can be hysteresis loss, it can be H equal to I square loss, I square RT loss, it can be other losses as well. It can be copper loss, fixed loss. Okay, AD loss. Okay, there are multiple losses possibilities are there. So this way, this hydraulic calculation is done. Okay. So this is a very good concept to do hydraulic calculations. So you see the for 21 meter cube, the motor current is how much? 55 amps. Now, if you make it 30 meter cube per hour flow, so motor ampere is being changing here because it is calculated in the different way. So this is the way you have to do. Okay, so this way you have to understand how the things are moves on, and this way this hydraulic calculation is being done. Okay, I'm showing another Excel that would be you can understand very easily. Yeah, now please see this one. Yeah, I think on Excel is visible. Am I right? Yes. Now, if you see the capacity is 150 meter cube, height is 60 meter, pump efficiency 70%. The pumping power is coming how much? 24.5. Okay. So now, if you change the meter cube per hour, like if you are making 200 meter cube, you see pumping power is 32 kilowatt. Set power is also changing. In the performance curve, whatever we have explained, that is shaft power. Okay, it is neither pumping power nor motor power. Okay, that you have to remember. So if I ask you one question, please make it 200, 250. Okay, 250. Just make it 250, and you see how much ampere is there. It is 96 ampere. Okay, so this way, if you change this, you'll get certain value of ampere. This is one way of approach. There is another way of approaches you can do with the help of goal seek operation. Okay, this operation in Excel, just please try to learn, because this is very much helpful for your activity, academics, academic activity. So now if you see, now for 250 meter cube, the ampere is taking how much? 96. Now you just do this goal seek. Goal seek, how to do? Condition formatting. Click here, then just not here. Okay. So if you click here, goal seek, you can find. Yeah, it is what if analysis, not condition formatting. Sorry. If you click here, what if analysis, just click on goal seek. Okay. Goal 6 means, suppose this value 96. Okay, if I say you, please tell me at 85 ampere what would be the flow. I am writing it 85. Okay, so this value I have selected at 96.393 here, over here, and this value 85 I want the ampere. So now please tell me what would be the flow. You just, by changing which cell, just click it here. Okay, so now make it okay. You see 85 ampere, the flow would be 219.2. Okay, so this way, from the answer to question also you can move with the help of this goal seek operation. Okay, so it's a very fantastic tool, just use sometimes. This is one way. Second way, you can keep on changing this one to make it 85, like 250, 200, 90 in here, it's not 84.9. Okay, this way. But this is for the input to output. For output to input also you can operate with the help of this goal seek. Okay, just goal seek operation, please remember, this is very helpful for doing calculations. Okay, so now the point is how to do this pump flow. Okay, pump flow, the concept comes from the mass balance. Okay, there's a concept of heat mass balance. So from there the pump flow requirement comes. Okay, and pump head requirement comes, as I was explaining to you. This is the pressure drop in the pipeline. Okay, this vertical lift and this horizontal pipeline, there's a pressure drop, and cumulatively concept is the pump, whatever pumping pressure is there, it should overcome all the pressure drop, so the fluid can go to the tank. Okay, so this way it is being calculated. Okay, so this is the basic concepts. So now I'll show you something. Pump part is over, so I'll show you one thing that is related to some industrial thing. Okay, some pictures, you just see, you can correlate with your basic curriculum. So I was explaining to you at very beginning, if you want to operate a plant, you have to operate it in automation. Okay, now it is not manual. Okay, you go to site, you'll operate all the valves. Okay, it's not there. It's totally controlled from DCS or PLC or SCADA. Okay, it can be DCS, distributed control system. This can be through PLC based on number of input and output, AIO, or it can be SCADA also. This is how it looks like. It's like the three people are sitting here and they are watching the DCS. Okay, and you have to operate this. There will be small computers. These are called HMI, human machine interface. You have to operate here in the site. Okay, so this is how the things are moved on. And there's a very important concept of redundancy and safety integrity level. When you go to plant, you see what is the concept of redundancy. Redundancy means for a same assignment there will be two instruments. Like if you are, maybe you are sitting in a room, you are having two number of AC, air conditioner, to make the room cool. What is the purpose of two numbers? Because one number is sufficient. The purpose is, if one number malfunction, then another AC will take the load. Okay, so that you can keep, suppose in the room cool, or suppose you have a very important instrument, very important medicines that has to be keep cool always. So then you have to go for seal 1, seal 2, seal 3. For same assignment, 2 AC, 3 AC, something like that. Safety integrity level is something like that. For same assignment, you are putting multiple instruments or multiple entities which will follow the same assignment. Like you are measuring the level in a vessel and you are putting two number of level indicator, but one level indicator is sufficient. The purpose is if one level is fall, so it is a toxic chemical, it should not overflow. Another level will take care of the level. Okay. So this is how things are good. This is the architecture. I will not go into detail on that. Okay. This is the very basic thing you have to remember. You have gone through this in control system, how this feedback control system looks like. Okay, please remember this is often in asked in interview also. Set point, PB, how error is generated, it's going to controller block, then how PID tuning is happening, the basic equation, Kc tips into epsilon plus Kc by tau I, integration d epsilon by dt, this basic equation plus Kc tau d epsilon by dt, this PID concepts, these you have to remember, is very important concepts. Okay, so different flow meters are there because nowadays this concept of chemical engineering is much more aligned with the instrumentation engineering. Okay, you have to know instrumentation very well, then you have to know electrical also to some extent, you have to know civil engineering to some extent also, mechanical is very much you have to know, you have to know instrumentation very much, you have to know mechanical also very much, then to some extent civil and electrical. Okay, because once you work in a plant, you have to go to troubleshooting. If you do not know the working principle of instrument and all these things, then you cannot do the troubleshooting. Okay, so these are very important. The different flow meters that is being used, this variable area meter, variable head meter. Variable area meter is very common in industry, rotameter very well. Head meter very common is orifice meter, venturi meter. These are very commonly used. Okay, and as I was explaining to you, you just remember for a fluid four important parameters like what is the fluid type, what is the temperature, and what is the flow, what is the composition, okay, what is the density, what is the viscosity, thermal conductivity, specific heat. Okay, these are the important factors that you have to. Same for the control valve design also. Once you go for this control valve design, you need to put all these things. Okay. So this things how looks like. So this is called CV calculation. Once you want to design a control valve, this CV calculation is very important. CV calculation means the flow in GPM for 1 psi pressure drop across the valve. This is very important terminology. What does it means? That flow in GPM means gallons per minute. If you pass flow in GPM and across the valve, there is a pressure drop. If you see this valve, small valve, you're creating a pressure drop of 1 psi. Okay, and the flow is passes to the valve. How much flow for one will pass at 1 psi pressure drop? That flow, if you measure in GPM, gallons per minute, that value is called CV. CV is called valve coefficient. This is very important terminology for control valve design. Okay, so this is how a under dam system works. This delay time constant 63.2%, and this all these things. And there's a two concepts here. Industry also you see there's the concept of offset, there's a concept of oscillation, how to reduce the offset and how to reduce the oscillation. This is a typically control valve looks like. Okay, if you go, suppose this is a one pipeline and outlet pipeline is this. This is the top of the is called actuator. There's a positioner here. This is when the signal transfers this 4 to 20 milliamp just gets converted, and there's the actuator. So this works. Okay, this is how a rotameter looks like. Okay, so rotameter is basic feature is like that. Rotameter mostly is installed in the vertical line, and flow direction is normally from this direction. Okay, from the bottom to top, and there's a float here. This float is balanced by three forces. One is called the weight, that is uh, working in the downward directions, and there are another two forces, and it's called drag forces, another is called buoyancy forces. Okay, so based on that, the float position changes. Once you increase the flow, what will happen? The drag force will increase. Weight is almost fixed, buoyancy is almost fixed because it is fully submerged body as per the Archimedes theory. Okay, so this is the basic principle of a rotameter. This is how the venturimeter looks like. This is the concept of vena contracta here. Okay, this is upstream position, this is the throat position. There are two tapping, and these two tappings are creating the pressure drop. Based on that pressure drop, there is a fundamental equation. You know this how to calculate this flow. Q equal to C0 into A0 root under 1 minus beta to the power 4 into delta P by rho. So this fundamental equation of pressure drop and flow, you have to remember that how to calculate this. Okay, this is this is a in industry mostly temperature indicators are RTD or thermocouple. Okay, these are very common. There is a pipeline and this temperature indicator is put here. If you see here, so what does this temperature indicator is doing? This is basically RTD, resistance temperature detector. Okay, you just go through in your control system with many temperature indicator, but mostly RTD is used in industry. Okay, RTD or thermocouple. If it's a very higher temperature, then we can go for thermocouple. So there's another concept of pyrometer, all these things are there. SR measurement also, capacitance type and piezoelectric type, these are very common, around 99% case in industry. Flow measurement, pitot tube, venturi, orifice, these are very common. Mostly, if you see in industry, these are being used. Liquid level also, it measures the delta P and it measures the flow by this way. This is how a this is how a DCS looks like. Okay, you see that some of the vessels are levels are in green color, some of the vessels levels are red color. Red color level means the vessel level is going out of range. It can be lower side, it can be upper side, because there is a boundary condition of the level that is put by the DCS operator. Maybe level is operating 50%, the boundary condition is 30% is minimum and upper condition is 80%. How to fix the minimum boundary condition? Minimum boundary condition, suppose for this vessel, is to fix by based on the pump cavitation. Okay, if the level is going down, then pump cavitation tendency will go up, because of the NPC's availability will be less. Okay, so you have to see what will be the value of the NPC's available. There should be sufficient gap of available minus required, as maybe 1 meter, or the ratio is more than 1.3. Okay, so based on that, minimum level is fixed. How to fix the upper level? Upper level is fixed to avoid the overflow. Okay, if you overflow the vessel, then there will be problem, because it can be catastrophe as well. So the upper level is fixed based on that only. Okay, so this way, maybe this level is showing red, means maybe it has gone upper side or lower side based on the setting. Okay, so this is how the DCS page looks like. Okay, there are different interlocks are there, sequence table is there. Okay, this I explained to you. This is, you see, just one. So there is a orifice meter over here. So it's measuring the pressure drop. Okay, once the pressure drop is created, the pressure drop is being converted into the flow PV, as I explained to you. Process flow that's going to DCS through 4 electronics signal, 4 to 20 milliamps. Then when it is this 4 to 20 milliamps is coming over here, then it is being converted into electropneumatic by the help of electropneumatic positioner. Okay, so which converting 4 to 20 milliamps to 3 to 15 psi or equivalent pressure rating. If there is a booster wheel and other things available. So now it's going to the final control element, control valve, and it is working. Okay, suppose PV it is measuring 40 ton, and your set value is 30 ton. So what will happen? This is will instruct this valve. Please reduce the flow. Please close it. Okay, by the help of this signal, it will work accordingly. So this is how a control system looks like. I just tried to give a brief explanation on that. Okay, so I'll show you another industrial view. So this is a turbine. Okay, and turbine is very common in industry. Okay, this is how the turbine looks like. Okay, so turbine probably have gone through the concept of heat engine in thermodynamics. Okay, and chemical engine case, thermodynamics is not that extent, because they are in the mechanical engineering. So thermodynamics basically it follows the Rankine cycle. Okay, thermodynamic cycle you have gone through this Carnot cycle, Breton cycle, diesel cycle. So this is basically nothing but a Rankine cycle. Okay, so steam is flowing in this direction, and the steam energy enthalpy is being converted into the power finally. Okay, so heat energy, heat to work, when it is doing certain work, heat is converted into work with the help of heat engine. Okay, this is called a heat engine, where we are converting this heat into work. Okay, so this basic principle is there. Like if friction, you use this Modi chart. Okay, this Reynolds number is there in x-axis, and the y-axis there's a friction vector, and this EYD is the this is called Modi plot. So this for turbine you have to use the Mollier chart. Okay, Mollier chart is very common, that is being used in turbine calculation. Okay, this is a isoenthalpy and entropy diagram. With the help of that, you can isentropically you can let down inside the turbine. You can calculate how would be the power recovery. So it's a kinetic energy converting into electrical energy. Steam system is not that extent in syllabus, but steam is very important in industrial perspective. Saturated steam, superheated steam, and it's isoentropic process. Turbine Like isoenthalpic process you have gone through throttling, like if you are changing the pressure through a very small opening, okay, the change of pressure delta p divided by delta t at constant enthalpy is called Joule-Thomson coefficient. Okay, this is isoenthalpic process. For turbine process it is isoentropic process. Okay, remember this one. So turbine is very complex subject. There is a impulsive turbine, reactive turbine is there. This is how a restricted orifice looks like. Okay, orifice means it will create some pressure drop in the pipeline. Okay, by the requirement of the system, it requires some time to create some pressure drop. Okay. So this is how a orifice. This is heat exchanger. One side I have shown you a picture, and tubes are taken out in the right hand side. This is heat exchanger tube seats. In the small holes there are tubes in the heat exchanger. This is cell, and this is tube seat that is connected with the heat exchanger. This is how the fouling is there in the heat exchanger, that you can see that how tubes are getting blocked. Okay, so once any heat exchanger is in operation, you have to calculate the heat transfer coefficient. Okay, heat transfer coefficient, you know, this concept of UC and UD, then dart factor, UC minus UD 1 by UC, and this concept of dart factor. So that you have to calculate this overall heat transfer coefficient, and you have to see that how overall heat transfer coefficient is changing with respect to time, with respect to operation. There will be some natural decay, there will be some forced decay. Forced decay part, being a chemical engineer, it is our responsibility to stop. Okay, natural decay may be there over the period of time, some settlement is there, tube exterior, tube interior, some deposition is there to reduce the heat transfer coefficient. But that is, if it is a natural decay, that you have to take care through the dart factor consideration. Okay, RD, when you are considering this dart factor while designing of heat transfer area and some heat transfer area. Okay. And if it is a fouling by some means, then the available heat transfer area will reduce. Then out, maybe if it is a heating purpose or cooling purpose, that will be affected. Okay, so that you have to take care. Or this plate is, I have explained to you all these things. Now, before that, what I explained to you, this, you know, there are so many things are there. It will take huge time to explain everything. Yes, I'm giving you one brief. Okay, you are in chemical engineering discipline. The things whatever being used in industry. Okay, so some of the calculation you just try to learn. It is there in the textbook also. You can refer it everywhere it is available. Okay, I'm just giving some gist. I'm sharing on Excel. Just just follow me. Okay, so I think it's available with you. You can see it. Okay. So overall of a manufacturing process, I have explained to you at very beginning the what is the manufacturing process. There will be some raw material, there will be some product. To convert raw material to product, there will be change in chemistry. Change in chemistry means you have to go for the reaction, otherwise it will not happen. Okay. The unit operation process, I said, Excel you have to know very well. You have to very prepared about the Excel and PowerPoint presentation. In Excel, there are so many works is done, and this compressor power calculation. Okay, this is also, you know, in thermodynamics probably have gone through this isochoric process, isothermal process, adiabatic process, isobaric process. But industry mostly it is a polytropic compression. Okay, in industrial process whatever we can do the calculations based on the polytropic compression, like PV to the power n equal to constant, n not equal to 0, not equal to gamma. Okay, n, the value will come, it is a monoatomic or diatomic, there will be such certain charge. Based on that you calculate this value. Okay. And these are very common, BFD, PFD and PNID in industry. BFD is called block flow diagram, PFD is called process flow diagram, and PNID is called, sorry, PNID is called piping and instrumentation diagram. Okay, these three diagram you have to know once you go to industry. There will be another complex diagram like isometric diagram, general arrangement drawing, GAT. There will be other layout drawing. There will be other concepts as well. Okay, so now uh, Molière chart I explained to you. Friction chart you already know, I believe, because it's a Modi plot you have to use. Free settling and Hinda settling concept, the Stokes law, that very fundamental theory, and it is used for the, you know, when there's a gravity settling, gravity separation. You have to remember how to calculate this terminal settling velocity. Okay, dp square g rho p minus rho by 18 mu, this basic formula. Okay, then it comes to control valve sizing. Control valve sizing I was explaining to you. There are different formulas are there. Mostly these are empirical formula. and you can get it from the book of Perry. Just try to buy one book of Perry and keep it with you. Okay, this is a very important book and help you in future also. All data, all graphs, everything is there. Okay, and you know how to just navigate inside the book, how to find it out. Pipeline hydraulic calculation, I explained to you this Hagen-Poisson equation. By the help, this is a equation mostly used as per I did my calculation. Okay, these are and also very important is the unit consistency. Okay, whatever calculation you are doing, always try to understand the unit part. Otherwise, whole thing will be in damp. Okay, so this pump performance impeller NPC state vessel sizing is a static design concept is there. Mostly ASME is followed. The API is for the mostly rotary and ASME is for static design. Entertainment characteristics, it is the RO sizing, choke flow. Okay, void calculation and heat exchangers. These are different calculations are there. Ball topping ASME API standard. You know, there's a concept of there's a question that who are the engineers? Engineers are those people who follows the codes and standards. Okay, you cannot do anything by your own. Okay, everything has been laid down. Okay, everything has been written. Okay, you have to follow first. Okay, you can be a developer, then that time you can develop, but not for everyone be a developer. Okay, you have to follow certain code and standard. So mostly it is a API code or ASME code that you have to follow. Okay, different, like for laboratory specification ASTM is followed. Okay, API is followed mostly for rotary, ASME is followed mostly for static. Okay, mat calculation is very important. This is called minimum allowable thickness. This again comes into the static design. Okay, a certain formula is there. P into epsilon by 2 into T. With this formula, it is done. Third choke characteristic is very important. Like for palm is the performance curve for and for this compressor this is hard choke characteristics. Okay, control system I explained to you. You have to know being a chemical engineer. You have to know control system, and you have to know very well the control system stability criteria. How does stability happens? Okay, to some extent, if possible, Nyquist plot, Bode plot, and this you have probably gone through. It's a little bit complex, but okay, as per your time and this recommend permit, you have to go. Controller calculations, furnace efficiency. Furnace efficiency calculation is very interesting. You have to do spray sizing, mass transfer, all this pressure drop calculation is very common that you have to do. Heat loss calculations. Okay, heat loss calculations is this different temperature pressure element how it behaves. Okay, and goal seek I explained to you. This is one of the important part. Different flow meter distance time. Process safety management is a very interesting thing that you have to do. Okay, this is also very important. Now it's coming to the simulation part. You might have these questions probably. You'll be asking this. If you're in the fourth year now, just try to get into simulation. Very important. Okay, like for process simulation, process design, you can use Aspen Plus or Aspen HYSYS. Aspen HYSYS is the latest version of Aspen Plus. There are other attributes are there in Aspen HYSYS. If it is a heat exchanger design, you have to use HTRI. Okay, Heat Transfer Research Institute. Okay, and other than Aspen, there's a software like Pro2, Unisim. There are many softwares are there, but Aspen is one of the user friendly and having a huge repository of information inside. Okay, you can follow the database, all these things. Okay. So this is how the things are moving on. Okay, so if you want to see the Aspen window, how it looks like, you probably are having this license in your institute. Okay, just try to learn something. It's very important for the engineers. Firstly, you have to know the fundamental part. Aspen window, I'm sharing how it looks like and how it is done. Then I'll close the session. Okay, so before that, I'm sharing my computer first. Okay, just see how it looks like. Now I'll open one Aspen file. Okay. Probably I think it's visible. My screen, my computer screen is visible.
Yes, sir.
Okay. So now you have to connect it here. So whatever I have explained to you, all chemical engineering theories, this is a software where everything has been included. Okay. I'm showing you a very small thing. Okay. There are very complex things inside. Okay. So you have to learn it. Okay. If you see whatever I explain you the basic chemical engineering, if you just click here data browser, if you see here you have to click here setup suppose. Okay. If you see setup, this is steady state simulation. Okay. this input data, output data, description, accounting, all these things are there, simulation options. And if you make your own unit components also, you have to define what I have just defined. Water is a component. You can write anything else here. Okay, it will come. Okay, if you write here acetic acid, ACETI, acetic acid, acetic, suppose it's something else. Maybe it has not been identified by the system. Then you click here and delete here. Okay, delete the row. Okay, no problem. Now if you this setup is done, now the components is done. It comes to the properties. Then properties means you have to understand which kind of properties. This is thermodynamic model is there. Absolutely here the base method is Payne Robinson. Okay, there can be another. You can put the NRTL, NRTL Hawk, NRTL RK. Okay, the different thermodynamic model is there. You have to select it. So for that you have to understand the fundamental part that I explained you last 45 minutes. The fundamental has to be clear first before moving into this navigation window of design software and this simulation, all these things. So fundamental has to be very clear. The different streams are there, blocks are there, conversions are there. Now is suppose here over here. Okay. So now if you click here, this line you can see this is supposed to be okay. This is supply. I'm changing the stream name. I'm writing it supply SUP. Okay. And this is a delivery. Okay. I'm changing the stream name over here. So Control M. So this is delivery. Okay. Delivery, right? So now supply, how much is the flow? You just click on the line. You see the flow is 150 meter cube per hour and zero point 0.1 kg, 35 degrees Celsius mass. Thank you for your response. Uh, so I'm here. Okay. So one model is here. So my model is, I can see that what is the flow here. Okay. Flow I have given certain flow. Okay. Maybe flow 150 meter cube per hour. So now what I have to do, I have to specify the block. The block specify means I have to see suppose 8 kg. Suppose I am saying that I require 10 kg pressure. Pump efficiency 65%. Maybe I am making it 70%. Okay. Then driver means motor here. Okay. So now if you want to run the sequence is ready. Yeah, all inputs is complete. Sequence is ready to run. So what you have to do, you have to reinitialize purge one time. Okay. So now you can run the sequence. Okay. Now running the sequence means you see the run initiated and okay, your block has been executed. Now you see the result. Okay. Result means you just go to the window here, click here and see the result. Okay. So how much power is coming? The power is coming around 41 kilowatt. Okay. Just move it to kilowatt. It is showing watt. So if you make it to kilowatt, kW. Okay. So it is 41 kilowatt. Okay. So for pumping 150 meter cube of water, is taking 41 kilowatt. Now if you want to change it, suppose if you change it 200 meter cube. Okay, suppose 200 meter cube you want to change. Okay, just drop all the old values. Okay, reinitialize, just run the sequence again. Okay, so you see, okay, your sequence is running. Okay, your okay, Aspen is converged here. You can see the result here also. You can click here, you can just go to the block and you can see the result here also. It's coming for 54 kilowatt. Earlier it was how much? For 150 meter cube, it was 41 kilowatt. Okay. So this way Aspen is also helping, but before running Aspen, you have to know the fundamental first, because you have to know how the pump is happening and what are the degree of freedom. Okay. And because otherwise you sometimes you'll go to over specify or under specify certain streams. Okay. These basic concepts that you have to, what are the different type of thermodynamic models. Okay. So then you can get into that window. So this will help for further simulation, because pen and paper you cannot change all these values all the time. Okay, very difficult to do all the time. Okay. This way you have to move on. There are another softwares out there. Unisim is there, HTRI is there. Okay, there are that you can use. And how to make this model? This is also very, very clear. This model I have made. What I did, pump is a pressure changer. You just click here, just select the pump, put the pump here, then click the material stream here. Just click on the red means it is a mandatory. Okay, you have to click here, then red it is a mandatory. Okay, you have to click here. Now what you have to do, you can connect this to this also. Okay, just how to do, for that you have to delete this stream. Okay, just do it, and you just connect this pump delivery here, and delivery, just what you have to do, reconnect destination and connect here on the red line. Okay, That means this pump discharge is coming here. So now I am giving certain inputs in the block. I am saying this is a pump model. Okay. So discharge pressure I am saying it is 8 kg থেকে এটা মনে করো হলো 18 kg okay. So time efficiency I have given something maybe 0.9, maybe driver efficiency I have also given something 0.85, okay. So this is also okay. So now your all required input is complete. What you have to do, you have to parse the all values first, okay. So all values first you parse, okay, and just delete few more things, these are not required here, okay. And your system is ready. Now you run the simulation, okay. You're running the simulation. I think it is also okay. Okay, both the blocks are successfully run. You can see here, or if you go here also, you can see that how much power this pump was taking, how much power this pump is taking. Okay, it is 54 kilowatt, as I explained you earlier also. Now I want to see the this pump. Okay, this pump how much power is taking. This pump how much power is taking. This is also taking 44 kilowatt because this pump discharge is coming here. Okay, and it is being pumping here. Okay. So this way the simulation goes on. You can select the heat exchanger model also, heater model. You can put here. Okay, you can just make the material steam over here. Okay, you can make one steam here. You can just put the information and put the block information over here. Then you can get the output. What would be these heat transfer values and all these things. Okay. So this way it moves on. So okay, this is from my side. Okay, if you have any questions. I hope you have some questions. Okay, you can ask, sir. Somak, sir. All right, no problem. Sir is in line. So, students, whatever questions you have, you can ask about chemical engineering, about this professional life in industry, or anything else. Your career, your study, everything. Whatever you feel comfortable, you can ask. So please don't be shy because I cannot see you on either sides. Okay, whether you are hearing me or not, I cannot judge. I cannot see anyone. So it's okay. No problem. Any question can be asked. Okay, you can just unmute and ask the questions. Okay.
Sir,
Yes, Deepesh, I can hear you. Please tell.
so can you briefly touch three-phase induction motor?
Yes, Deepesh. Three-phase induction motor. Why it is called in domestic purpose? We use single phase. Okay. If you're in a home, like you have a tulu pump or a jet pump, these are all single phase. Okay. For industry, whatever you see, it is three phase because the torque. Okay. The for domestic purpose, this power requirement is can be okay with a single phase, but for industry, if you use single phase, then it will burn. Okay, you cannot tolerate that much. This is very common understanding. So there are three phases. It will help to balance the current. It will help to fulfill the required torque. Okay. So why it is called three phase? Because there will be concept of R phase, Y phase, and B phase. There will be neutral. There will be earthing. Okay. And why it is called induction motor? Because basic concept, there will be always differences of this. The rotational motion of the magnetic flux and the speed of the rotor. Okay, that difference is called the slip loss. So there are certain slip loss is there. So for that, the rotor is always running to catch up the speed. This is called this concept of induction motor. It can be slip ring, it can be squirrel cage, and if it is a synchronous motor, then there will be separate DC excitation that is given on the rotor to get it magnetically coupled with the stator. So that is the basic concept. I think it's clear to you, Dipesh.
Sir, this question was asked by Vikram Rajput. My question is, sir, my question is
All,
that
all right.
why we, why centrifugal pumps are so much used? Because in industry there are so much long and high columns. As you say, centrifugal pumps provides velocity but not pressure. But in higher columns we need higher pressure, which provided by positive displacement pump.
Okay, yes, understood your question. Actually, centrifugal pump, one part of the pump provide velocity. Finally, this velocity is being converted into pressure inside the pump. Okay, so what I explained to you, this pump, the rotor that is moving at speed with the motor, so that is imparting energy on the fluid. So fluid is getting higher velocity. When this higher velocity fluid is moving through the volute, it is being converted into pressure as per Bernoulli's equation. Okay, so it is giving flow and pressure both. Suppose if you require 100 meter cube flow, 100 meter cube per hour, and maybe 10 kg, 15 kg, it is always is it's preferable is centrifugal pump. Okay, reciprocating pump is mostly it is a dosing type. Okay, or if you can use it for the very high flow, maybe 100 kg flow, but flow, sorry, maybe 100 kg per centimeter square pressure with a very limited flow, maybe 2 ton per hour, 5 ton per hour. Okay, but if you require very high flow, this is a typical design part. Okay, whatever I saying, maybe it is 90% true. There may be advancement in everywhere. Okay, it can be in the exception also, but typical design, if you require very high flow, then centrifugal pump, high flow and high pressure, then also centrifugal pump. But if you require very high pressure, low flow, then it is chosen as reciprocating pump. Okay, because of the design, because reciprocating pump works on the principle of top dead center, bottom dead center, live dead or depth dead. There is some swept volume that moves on a single acting or double acting, that is moves with the line. Okay. So this is the basic principle wise it is different. Centrifugal pump also creating pressure, reciprocating pump also creating pressure. Velocity is creating inside, that is being converted into pressure with the help of volute, that is casing in the centrifugal pump. Okay.
Yes, sir, understand. And sir,
Okay.
you say that if we increase ampere, flow rate will be increased. But sir, higher ampere cannot cause higher heat losses and damage the coil inside the pump.
Yes, yes, definitely. Increasing means there you have to certain limit is there. Beyond that, you cannot increase. Okay, flow rate increasing the ampere. Ampere is the result. Okay, ampere is not cause. Ampere
Okay, sir.
increasing, yeah, ampere increasing without increasing flow rate means that is dangerous. Okay, because ampere should increase only with respect to flow rate. Okay, so that is the thing. Okay, ampere is the result. Flow is the cause. If you are increasing the flow, ampere will automatically increase as a linear proportion. Okay, that I explained. Okay, anyone else?
Hello. Hello. So,
Yes,
I have one doubt.
yes, Jayashree. Okay.
Yes, sir. So, in crystallization process, they use peristatic pumps, sir, for mixing the solvent into the reactor at long times, sir. For
Ye-
example, one ml per 1 minute, 1 minute, sir. In this case, we have to increase the flow rate at low times, sir. It is possible.
Yeah, just it depends. I am not sure which process you have seen, because many is process to process everywhere. Every industry having their own strategy. Okay, so you can use peristatic pump. You can use high speed agitation. Okay, we generally use high speed agitation for mixing. Okay, but for crystallization, whatever you see, you said for the flow rate 1 liter per minute or something like that. It's very less flow rate. Okay, I'm not sure which kind of thing they are adding into crystallization. The basic concept of crystallization is primary nucleation and secondary nucleation. Okay, primary nucleation means where there's a abrupt change of solubility, there's a formation of nuclei, then gradually over the period of time it gets into overgrowth. Okay, so that is called secondary nucleation that is happening. Okay, and this mixing is also very important, because once this crystal will form, it will settle down if there is no mixing. So it can be done by pump, it can be done by agitation, but agitation is most preferable, whatever I have seen in my 15 years experience. But probably you are right, you have seen somewhere. Okay, so it depends. Okay, it is not having any thumb rule, it always varies industry to industry. Okay, Jayashree.
Thank you, sir. Thank you, sir.
Yes.
Sir, I have question related to industry and companies.
Yes, Dipesh, I can hear you, please tell.
Sir, my one of the relative is DSLR operator, and he just passed out diploma in chemical engineering.
Okay.
With he has some KTs in his past education life, but still he is working well and good company good paying him quite a good amount. So I want to ask how much education is needed and important for take get good job and good amount of quantity means good balanced job.
Okay, and I understood you. Some your question, some part is hidden, some part is okay, declare. No problem. So see, initially amount doesn't matter at the beginning when you probably I believe all of you are student. Okay, so you have to get into a job. So for that you have now your important is the academic score. Okay, once you're having good academic score you will get into a job. So after that it matters, okay, how many jobs you changes every job, maybe 20-30% there will be escalation hike. Okay, so it all depends, it may be double
Yes,
also.
sir.
Okay, how can you can prove yourself, it all depends. Okay, but
Okay.
initially your target should be the on academics, how to get into a good job. So now the definition of good job and bad job, it again explained to someone, just see. So it
Yes,
all
sir.
depend upon the satisfaction and the requirement. Okay, there is always, there the way we think it doesn't match the reality. Okay, so for that you have to put your effort. Okay, but it is not always education. Okay, it's your skill, your experience, and how your tenacity varies with respect to the adversity in the conditions. Okay, so it all things you have to cope up. Okay, and the balance job we expect after certain time. Okay, at very beginning time possibly you have to fight it at the very beginning. Wherever you join you have to learn it first, because probably whatever I explained to you, understand there's a gap between this academics and the industry. Because of
Yes, sir.
that you have to bridge this gap with your knowledge. Okay, initially, then gradually with experience you can expect a better life. Okay,
No, sir.
so
I know expense is important. He also started with 15K salary. Now it is about than 50K. But my question is how much education we should pursue? Because when I meet him one time, he said, I want to do degree because I am diploma pass out. I have no promotion in now further. We cannot
no.
progress more than this.
Yeah, yeah, it's all right. No, it all depends. I do not know you and him personally. Okay, it is in diploma also. It happens that people are getting promoted. Okay, so what kind of hierarchy structure is there in organizations? I'm not sure, but the basic industry standard in India is that BTech. Okay, diploma is there, definitely they are also doing a very good job. Basic standard is the BTech, and also if you're doing MTech and PhD, then you can go for this R&D and other sectors. Okay, you can go for development design
Yes, sir.
sectors. Okay, so
I
it is not having a direct answer because so concept whatever I explained to you I think is clear. Okay.
yes, sir. Concept work is, but I just want to know, MTech is really important that much, or we can, as you say, you
Yeah,
can.
in MTech, yeah, definitely. If you go up for higher studies, okay, there is no alternative on that. Okay, you can
Okay.
enrich yourself, you can enrich your knowledge, you can enrich your expertise. Okay, in that side it
Yes.
is important. But if you expect with MTech you'll get higher salary, that you have to see
No,
which
sir.
kind of industry. Yeah.
I not talk about salary. I mean, what opportunities are more available for me if I do MTech?
Yes,
Uh,
if you do MTech, then R&D will be very much exposed to you, okay, because they prefer generally masters. Because the difference is, suppose you are in BTech, you are studying this fluid mechanics. In MTech, you will be studying the advanced fluid mechanics. BTech, you are studying masters for. MTech, you will be studying the advanced masters for. Okay, so generally R&D sectors and design sectors, which are core design sectors, they prefer this master degree students. Okay, and if it is a industry manufacturing sites, then mostly it is BTech. It's very common, as I said, 90% case, but exception is always there. Okay.
Hello.
Thank you, sir.
Hello.
Yes,
So sorry
yes,
for the
Jasmine.
interruption, sir.
Yeah.
So now I am completed my internship, 1 month internship in soil life science, sir. Be there it is in Karnataka. In this company, there are many types of graduates there, sir. Or diploma chemical engineering students and B chemical, B tech chemical, M tech students also there, sir. And MSc organic chemistry students also there. In this case, I saw one man. He is a diploma in chemical engineering. He get a 40 k per month salary in this company, sir. Due to his skill, there is no degrees value in this company, sir. Based on the
Yes.
skill only, they will develop their
Yeah.
positions, sir.
Yes, yes, definitely. But Yeah, definitely you're correct, but maybe to whom you have talked, it has taken more time to get the experience, and now he can
Ah,
in a positions to deliver. Okay, that you're correct. Okay, it all depends when you go to industry. There is no thumb rule. Okay, you can prove yourself earlier, or it might take time to prove yourself. But as I was explaining to Deepesh also, that you have to develop your tenacity and keen to learn, keen to develop your skill, and you have to deliver. Okay, and attitude, respect. These are all important parameters that varies. Okay, but it's
yes,
okay.
sir.
Okay, yeah, it's okay. It's
In
possible.
this case, he had only 5 years of experience. He get 40K, and be chemical engineering student, he get 6 years experience or 7 years experience. He only get 50,000 or 60,000 of salary. There is no importance in graduation in this field or that field, sir. And other, I saw one sir, he is in production department. He also get 50K salary. He is a BE chemical engineering student. He said to me, sir, I want to do ME or MTech in chemical engineering. He said, your skill is must. You have only one heat transfer book. You have only one mass transfer book. You have to go through it. You have to improve your knowledge. It will help. But BTech, after completing your MTech, it is also give a knowledge about that heat transfer, that mass transfer. There is no difference in BTech or MTech, whatever it is. You have a knowledge, you have a skill means you will develop your knowledge and you will get more salary in this company. The skill is important. There is no difference between you are BTech, you are MTech. Even MSc organic chemistry students also 8K salary. They are in production
Okay,
department.
okay, okay. Understood, understood, understood. All right. So it's not always correct statement, Joyce. Okay, they are doing diploma. It is not always better not to standardize with respect to salary. Okay, so things is there. If you go for BTech and MTech, you will get more clarity in the your knowledge and everything. Okay, it always values. Okay, now you are being a student at very early stage of your life. Okay, you cannot understand all these things, but it's okay. Okay, it is not required to explain in such a way. Okay, it is okay. Choice is yours, but I will prefer definitely for higher studies, because if you can continue higher studies, that will give you a different kind of pleasure and development in life. Okay, definitely it matters, but it's going better to go for higher studies, and skill will come definitely. That is your tenacity and the way you want to learn everything, it will come automatically. Okay. So, anyone having any other questions related to anything, so you can ask.
Sir, our this internship is over now because scheduled all lecture are complete.
Oh, your all lecture complete. Okay, sir is in line probably. Sir, uh,
Because some topics like hydrogen, green hydrogen generation are some topics are new, some topics are not in schedule. So I want to ask: is lectures are continuing when new sirs are available, or all finished?
no, actually, Deepesh, that sir can tell you. Sir probably in mute condition. I cannot hear sir line. Okay. So anyway,
Okay.
sir will give the clear instruction to you. You probably having WhatsApp group or something. Okay. So sir
Yes.
will give the all instruction. Okay.
Okay.
If you have
Thank you,
any
sir.
yeah, all right. If you have any technical questions, anyone you can ask. Okay. No one is asking anything. Okay. Now, yeah, it's already 8:52 p.m. Okay. All right then. Okay. Thank you all.